Today, lesson 12C, angle relationships and solving equations. In 11C, we talked in full detail about angle relationships and what happens when you have parallel lines. When you have parallel lines, lots of special things happen, like corresponding angles, like alternate interior angles, like alternate exterior angles, and like same side interior angles. Today we're going to extend that a little bit by the idea of sometimes we can solve equations to find the angles that we are trying to find. So, some background knowledge here, and this says recall from yesterday, but it's actually last week sometime. All of these things, vertical angles, complementary angles, supplementary angles, corresponding angles, alternate interior, alternate exterior, same side interior, these are all things that we talked about in 11C. Some of them we reviewed from 7th grade, and some of them were brand new ideas. And then the triangle sum theorem, and we extended off of that exterior angle. We also talked about 4 angles in a quadrilateral add up to 360 degrees. And then we talked about parallel lines cut by a transversal, and all of those things that I already mentioned. So things like corresponding angles. I'm trying to go through this as fast as I can here. And those are corresponding angles. And we talked about the fact that those are congruent for things that we talked about earlier as far as rigid motions. In that case, it was a translation. And here are the rest of the corresponding angles from that picture. And then we extended that to alternate interior angles, and those two are really congruent because of rotations. And then same idea with alternate exterior angles, and those are congruent once again by the transformation of a rotation. And then we talked about same side interior angles, which have a sum of 180 degrees, and those are congruent because of the idea of corresponding and then a translation, and so on. And then we went through a couple of pictures like this where we had a ton of angles that we had to fill in, and we utilized all of those things that we just talked about, and we only needed 2 of them to fill in all the rest of them. And so that leads us to today. How do we really know that lines are parallel? Well, in your notes you have parallel lines JK cut by a transversal, and then you have lines DE cut by a transversal. And in number 1 it says this. It says, suppose you are given 2 lines J and K in a picture below. You have been asked to determine whether the 2 lines are parallel. You start by drawing a transversal L, and that is already in your notes, through the 2 lines shown below. Devise a strategy to determine whether the 2 lines are parallel using what you know about properties of rigid motion. Next, use your strategy to determine whether D and E are parallel. Just saying they do not look parallel is not a justification. So I'm going to give you a couple of minutes with your shoulder partner to talk about how you know whether J and K are parallel or not, and then the same thing with D and E. Okay? And you want to utilize rigid motion in part of your discussion. So I'll give you about 2 minutes. Go ahead. Do these and show you what I'm talking about. So if we have transversal L, right there, the red angle, and I probably should make it a little darker so it's a little easier to see, but if I translate that down, and that's kind of what Hunter was talking about, we can clearly see that we have corresponding angles there, and that means the lines have to be parallel. Or I could rotate it around like that, and then I could translate it up, and we can see by doing all of these things, all of these transformations, that we must have parallel lines here. I'm doing some rotating and some translating and so on. Whereas when we take a look at D and E, and I draw a transversal L, watch this. I've got that angle right there. When I try and translate it down, it's clear right now already that those 2 lines are not parallel to each other. D and E are not parallel. And I'm going to keep rotating and translating and so on, but we can clearly see we don't have parallel lines here. And so now I know that you've got some blank areas that you need to fill in for both of these pictures. The picture on the left, so when we take both angles, translate and rotate them, And the angles will still stay the same, therefore the lines are parallel. Seems like we should have some commas in there somewhere. And then on the right, when we take both angles, translate and rotate them, we see that the angles do not line up, therefore the lines are not parallel. So not only do we have some grammar errors, we have some spelling errors in the paragraph on the right there. So I'm going to stop for a second to let everybody get caught up. All right, so in the next several problems, we want to determine whether the following sets of lines are parallel or not, and we need to justify our response. So I'm going to do number 2 with you. So the question here is this: is P parallel to Q? Why or why not? Well, I can see from the picture there, because of the 110 degree angle and the 110 degree angle, that those lines must be parallel to each other. And the reason is because those two angles are alternate exterior angles. And if lines are parallel, alternate exterior angles are congruent to each other. So yes, they're parallel because the alternate exterior angles are the same. All right, let's take a look at number 3. Are lines M and N parallel to each other? Yes or no? And how do you know? Any ideas? John?
No.
Why not?
Because, so the line right there, and you see where 86 degrees is?
Yep.
If you, since that is supplementary
Yep.
to the angle on the other side, that would be...
To the adjacent angle?
Yeah.
Yeah.
And that would be 94 degrees.
Okay, so let me fill that in.
And that's not congruent to the 91 degrees.
Yeah, so what John is saying is that these two angles right here are supplementary. They add to 180, so that would make the other angle 94 degrees. And then we can clearly see these are supposed to be corresponding angles. They're not congruent to each other, so therefore those lines cannot be parallel to each other. Okay? All right. Go ahead now and do, same idea, go ahead and do number 4 and number 5, and then we'll compare with our shoulder partner, and then we'll talk about them. Number 4. Are they parallel?
Yes,
How do you know?
because the alternate interior angles are the same.
Okay, good. Those are alternate interior angles from that picture. They are congruent, so therefore those must be parallel lines. Max, how about number 5?
No, because the corresponding angles are not the same.
Yeah, and basically this is very similar to number 3. If we find the angle right there, the supplementary angle, that's going to make that 89, and then those two corresponding angles, or what are supposed to be corresponding, are not congruent to each other, so therefore those are not parallel lines. All right, so let's go to the main theme for today, which is using equations to find missing angles. So I'm telling you in number 6 that those two lines are parallel to each other. And we can see from the picture that I'm telling you that this angle right here is 2x plus 10. We can see from the little red square there that that's a 90-degree angle. By the way, what kind of angles are those two angles that are given in that picture? What are they? They're corresponding angles. What do we know about corresponding angles? They are the same. They are congruent to each other. So what that means is that we can set up an equation that looks like this. They are supposed to be congruent, therefore they are equal to each other. And from that, we can solve that equation by subtracting 10 and dividing by 2. So that would give us x equals 40. Now all we are supposed to do here is find x. So that means we are finished. Yes?
Isn't that 20x?
It is 20x. Thank you. So that makes this x equals 4. Thank you. All right. So what we're going to be doing in the next 3 or 4 problems is this. We have to look at what's in the picture, think about the relationship between the angles, set up an equation, and at this point we're just solving for x. Now if we were told to find that angle, we would substitute the value that we got for x back in. But I believe in all these for today anyway, we're just asked to find x. So let's go ahead. I want you to do number 7, 8, and 9, and then I'll have you compare things with your shoulder partner. Number 7, these are alternate interior angles, and alternate interior angles are congruent to each other. So therefore, the equation should look like this. 11x minus 2 equals 75. Solve for x by adding 2 to both sides and then dividing by 11. So x is 7 in this picture. Number 8, we have vertical angles, and vertical angles are congruent to each other. The 90-degree angle is vertical to the 15x minus 30. So our equation would look like this. Solve for x, and we get x equals 8. In number 9, we have a picture that looks like this. Now, I saw people doing different things in this one. I saw some people finding this angle right here, which happens to be 108 degrees, and then using alternate interior angles right here. But you don't have to do that. And the reason is because those two angles that are given right there, those are same side interior angles. And same side interior angles have a sum of 180. Now, would it be incorrect to find the 108 and then do 12x equals 108? No. No. There are multiple ways of doing these types of things. So regardless of how you did this, you should get x equals 9. So any questions about 7, 8, or 9? All right, so let's go to the back side of the notes. Now we extend on ideas from the last lesson where we're simply returning to the idea of trying to find missing angles. I'd like you to go ahead and try number 10. All right, could somebody give me what angle x is, please? Just shout it out. What? 59 degrees. Now, once we have that one, we have this triangle right here. And the triangle sum theorem tells us that 3 angles in a triangle have to be 180 degrees. Could somebody please just tell me what angle y is then? 57, do we agree with that? All right, once we find that angle, now we have the large triangle right here. So if I were to sort of redraw that, we have 57 here, a 90-degree angle here, and we're trying to find angle W right there. So what would angle W be? What is it? Is it 33 degrees? Pretty sure it is, because we have 57 and 90, and we're trying to make 180 degrees here, so that would make that angle 33 degrees. So once again, we have to find angle x first. Although I guess we didn't. We could have utilized the 90-degree angle right there and found the 26 right there. So I did it a different way in the lesson here. I found the 26-degree angle, which then allowed me to find W. So once again, there are multiple ways of doing these things. It doesn't matter how you get them. But W is 33 degrees, X is 59 degrees, and Y is 57 degrees. All right, let's go to number 11. Fill in the missing angles for number 11. So as you're going through number 11 and 12 and 13 and 14, you just want to think about the things that we've talked about. The triangle sum theorem. 3 angles in a triangle add up to 180. You want to look for vertical angles. Problems like number 12, you can utilize the idea of vertical angles. In all of them, you can utilize the idea of supplementary angles, 2 angles that are adjacent on a straight line. You may also be able to utilize alternate interior angles if you have parallel lines, or alternate exterior angles if you have parallel lines, or corresponding angles if you have parallel lines, or same side interior angles, which have a sum of 180 if you have parallel lines. So a lot of those ideas can be used in 11, 12, 13, and 14. Number 11, the first angle that we should start with, or we pretty much have to in this one, is angle E. The 64-degree angle and angle E are supplementary. That means they have to add up to 180. So that means that angle E is 116 degrees. And once I have E being 116, I now have the triangle that I can work with. I have a 116 degree angle, a 21 degree angle, and F. They have a sum of 180 because of the triangle sum theorem, and so that would mean angle F is 43 degrees. Any questions on number 11? That one should have been easy. All right, number 12. Here I can see we can utilize vertical angles and supplementary angles and then the triangle sum theorem. Lots of places that you could start. I'm going to start with the fact that angle R is 95 because it's vertical to the 95 degree angle. From there, I will go with the idea that angle Q and the 154 degree angle are supplementary, so that means angle Q's 26. Now I can use the triangle sum theorem if I want to, because I have angle R and Q, and that means with angle P they have to make 180, so that means angle P is 59 degrees. And now I can use some more ideas of the fact that S and T are vertical, and I can utilize the fact that angle R is supplementary to angle T and angle S, and so that means S and T are both 85 degrees. Any questions in number 12? All right, number 13. We keep getting a little more complicated here. I'm going to start with the fact that angle 3 is vertical to the 67 degree angle, and angle 3 and angle 5 are alternate interior angles because P and Q are parallel to each other, and angle 5 and angle 7 are vertical angles, so all of those are 67 degrees. From there I can use some supplementary angle ideas, and that would make angle 1 supplementary with 45 and the 67. All three of them add up to 180. Angle 1 is 68. And I know that angle 1 plus 45 degrees is equal to angle 2 because they're vertical to angle 2, and that makes angle 2 113. And I know there are lots of different ways you could be getting these angles, not just what I'm talking about here. And angle 2 and angle 4 are alternate interior angles, and then angle 4 and angle 6 are vertical angles, so all three of those are the same. So they are all three 113 degrees for the reasons that I just talked about. Any questions about number 13? All right, I heard lots of good discussions in all of these with our shoulder partner, and then many reasons why angles are what they are. All right, number 14. First of all, I'm going to find angle 5 because it's supplementary to the 170 degree angle. And I know that angle 5 is congruent to angle 8 because they are vertical to each other. And it's also congruent to angle 1 because 1 and 5 are alternate interior, or 1 and 8 are corresponding, all because T and S are parallel to each other. And also congruent to angle 3 because 1 and 3 are vertical to each other. So all of those are 70. And then 2 and 3 have to add up to 180 because they are supplementary. And since I already knew angle 3 was 70, that means angle 2 is 110. And then angle 2 is congruent to angle 4 plus the 62 degree angle because it's vertical to them. And that means angle 4 is 48. And 4 and 6 are alternate interior. But I'm also going with the fact that 5 and 6 and 62 make 180 because of the triangle sum theorem. And so that makes angle 6 48 degrees. And then 6 and 7 are supplementary, and so angle 7 is 132. Any questions about number 14? All right, last, we have the massive number 15. Some of you I know already finished it. Others are in the process of working on it, and some of you haven't even started it yet. But I'm going to come back to you in about 5 or 6 minutes, and then we will go through number 15. So everybody try number 15. All right, let's quickly take a look at number 15. This is the reason why number 1 in the homework doesn't have angle numbers in there, because it just starts to look messy as we start to fill things in. But really, in this problem, even though it looked difficult at the beginning, since you have two pairs of parallel lines, there are lots of angles that are the same. So you should have done lots of supplementary stuff, lots of vertical angle stuff. You had a triangle in the middle there that you could have used the triangle sum theorem. You could have used some alternate interior, some alternate exterior, some same side interior, which I used quite a bit in that problem, and so on. Any questions about number 15? All right, we are finished for today. Go ahead and get started on the homework.